one, and is someone who second timer who came back here. So he is a trailblazer in security, innovation, and education, and a visionary and luminary in the field of cybersecurity, and wears many hats. He's not only the founder and CEO of Amnasic Research Labs, but also the co-founder and CEO of Uno Academy, a distinguished trainer provider. And also with him is Omkar Mali, is a security researcher and seasoned infrastructure cloud security expert, leveraging his expertise in safeguarding digital assets for clients. So, how about a round of applause for our friends Arun and Omkar?
Okay. Har Har Mahadev. So today we are going to talk about the smart core of green infrastructure. It's nothing but we are going to focus on the uh, s- uh, the solar energy actually. So the reason for this, actually, there are a lot of attacks happen from, it's especially from the Chinese product actually. So how many people are from China over here? No one? That's good actually. So I would like to introduce myself. I'm Arun Mane, and I'm founder and CEO of the Aminasec Research Lab. Also, and the UNO Academy, which we do a lot of trainings in niche field for automotive and the industrial control system, OT, satellite, and uh, IoT, these kind of stuff actually. And I'm also co-chair in automotive cybersecurity in CERTIN. CERTIN is nothing but government body who regulates a lot of things in Indian area, Indian nation actually. And I'm also international speaker and trainer across a lot of conferences. And I'm a security researcher by choice actually. Still, I manage a lot of, engaged with the client and handling entire team. But I like to do a lot of research on different technologies. And along with me, I have my colleague. Is it audible?
Hello, hello.
It's too much. Yeah.
So, hi guys, I'm Omkar Mari. Right now, I'm working with Arun as the head of research at Aminasec Labs, and I'm a former bug bounty hunter. Right now, I'm finding interesting in IoT, automotive, and satellite. And right now, I'm researching under the mentorship of Arun, and yeah, I'm joining with you this the session. Yes, over to
Thank,
you, Arun.
thanks, Omkar. So, why we choose this topic actually, and why we are talking about? We found a lot of vulnerabilities in a lot of devices which are uh, going going to use or getting used in the solar infrastructure. So these are some headlines from May 9, May 14, or something like that. The the Chinese vendor, uh, controlling the entire solar plant without any a restriction, without any asking or any concern in that case. So nothing but some of the the US government, from also the Europe government, they understood something inside the devices, something in the back door, I would say in this case, that they can control or they can shut down the entire infrastructure in this case. So that was happened 3 months, 4 months back actually. But when I was researching this topic, particularly some devices, Chinese devices, Chinese product in this case, I found a lot of vulnerability with respect to hardware and the related to software in this case back in 2019. And then same thing occurred when I was, doing some project with the U.S. government, not U.S. government, U.S. client in this case, and we found same thing actually. So what exactly the solar farm over here? So if you see over here, like there, uh, when you talk about the solar farm, nothing but we talk about the two types of inverters. So one is central inverters, and second is the what we can say string inverters. So if you see the solar panels, the number of solar panels that is DC are converted. It's combined with a combiner box and then attached to the central box. But if you see on the bottom line, they have every panel, the set of panels, I would say like 60 panels in this case. Each 60 panels can be attached to the one inverter and then goes to the entire, in this case, it goes to the grid in this case. So these type of solar plants usually see in the infrastructure. It's kind of a typical infrastructure for the solar. Even after in the grid, you can see kind of SCADA system which can control the entire the central inverter, or we can say string inverter in this case. So this is kind of, in brief, I would say, you can see the parallels in series, they are connected actually, the solar panel, and that goes to the central inverter. And then again, it connects to the infrastructure, which through these some sort of the Modbus communication. Usually in the Chinese product, they use Modbus rather than any other communication like DNP3 or something like that. But they used Modbus communication, and that connected with the SCADA infrastructure in this case. Same like, I think so. Okay, that is central. So same, they have some sort of cleaning robots. So when we talk about the solar plant, there are many things comes into the picture. So these are, if you see the robots which are trying to clean the entire solar panel, because if you have some dust or anything, it will not, that photons not absorbed particularly on the solar panel in this case. So that's why they always use robot cleaner to clean the entire surface. So nothing but these robot cleaner also connected in the infrastructure. So they have some sort of gateway box, and they connected over the LoRa communication. So this kind of things are like wireless communication in this case. So in this talk, we are, the scope of this talk is on the string and the coupler, what we are going to see over here, not the cleaning robot. I mentioned earlier, this is part one. Part two would be like more focus on the SCADA infrastructure, robot cleaning, and what's not. But this part one, we are going to identify like low-hanging fruits, low-hanging bugs in this case. So they have also solar tracker in the sense, it will track the solar in the sense, it adjusts the angle. And if you see over here, in this case, you can see the motor, gears, and they have some sort of microcontroller. These again communicated over the LoRa communication, and they have some sort of communication box. And with respect to that, it tracks this sun actually, and it absorbs the solar like a photons, and then it converted to with the help of inverters, string inverters or central inverters in that case. So tracker to use to track the suns in that case. Even they have some sort of modes, wind mode, something, if they have incidents like they have typhoon or any kind of natural disaster, it try to come on 180 degree. That means wind mode. For that purpose, they use the solar track. So now we are going to talk about morely focus on the string inverter, because every string inverters have some sort of communications, and they connect it to the entire kind of SACU panel. SACU panel is nothing but the panel which usually come with coupler and the PLC, which takes the all readings and the statistics from the solar string and send it to the SCADA in this case. So every string inverter have their features. They are coming from a lot of other countries, even with the Chinese, and they have different kind of communication channel as well. So if you see, in reality, you can see those string inverters with the set of the solar panel you have, and that can be that can be 130 kilowatt they produce or 230 kilowatt depending on the different kind of solar strings they use in the solar panel. So usually you can see they have Wi-Fi, Bluetooth, or rather BLE in this case, and they can have USB, and along with they also can communicate over the mobile applications. So we are going to talk about this vulnerability. We also done a lot of things on the hardware side, but this is not talk about that particular thing. It could going to be second part in the future. So currently, if you see very precisely that you can see the solar and then DC current, it's converted. We have some sort of ET70. It's another kind of coupler they have. This coupler is nothing but they convert one protocol to another protocol, and that's again from China. And it talks on the Modbus, and this is what the typical infrastructure. So, so nothing but they convert DC power from solar panel into AC for grid and plant usage. That is the work of solar string inverter. And it's commonly used in large scale solar plant due to a cost effective. If you go for central inverter, very costly in this case. If you use the string inverter, it's very cheap in this compared to the central inverter. And that's why they use string inverters or micro string inverters they can use in this case. It provides centralized monitoring and control for multiple PV strings. It's PV, that's nothing but the solar panel. Integrated with plant SCADA system or EMS for remote management. So all in this case, these solars are communicated with the SCADA systems. So from the SCADA system, they can control anything. Like they turn off the entire system itself. I'm into the entire string inverter. So the next slide, we are talk about some the vulnerability which we found with respect to the BLE communication. So over to you, Omkar.
Hello. So yeah, so while we roaming on the field, there are some string inverters. They have the Bluetooth. So me and my team started the scanning, the Bluetooth low scanning, BLE scanning, and then we got the MAC address and the device.
Uh,
Good.
that's nice. Yeah. No. It's burning now.
So yeah,
I want to survive 2 days actually at least.
yeah,
Over to you.
yeah. So after that, we finding we connected that using the GAT tool, and we tap into the communication, and we created the log file using the Android. And after that, when you analyze, there are three log files. So when I saw in the three log files, the data, the value, data, and handle are same. So I just want to analyze the random, if there is a random value or something like that, but no, they're using the static value. So it's proved that that particular handle have the static value. So maybe it's turn on the inverter and the turn off the inverter, they're using the same value. So
So nothing but what we do, like we had a PCAP file for reverse engineering, and we found some sort of in the GATT protocol we have handle and the value. So handle are same, which is for responsible to write some command actually on the with the UUID, and the value is static in this case. If you turn and turn up, the both are values are same actually. It's depending on when the inverter is on and you send same command, it goes down, right? And if you down, it can be also the turn on in this case.
So after that we got some other values also. So using get tool we connected that in interactive mode, and we're just using char write request. So char write request, and then there is a 0x0025 handle, and that handle have the value. So we write that value, and we can see we can write the multiple values like three. Those are four unique. Sorry, two unique values, and yeah, we are able to write that values. So in next slide, you can see the video.
So in this video, what happened? The inverter is running, and we send same the handle and this exact value to over the string inverter. In this case, we are not able to hear the voice
Voice.
or sound. Actually, in this case, that inverter is still running, and once we hit the this command, actually it goes down, it's turn off, it's totally silent from the inverter. When we see the inverter, it's like it makes too much noise because it's converting the in the DC to AC in this case. So it's producing some sort of 230 kilowatt on that particular machine. So you can imagine the noise coming from the that string inverters in this case.
So
So in this case, he's going to write this command. The value is written successfully, and this is what inverter we have, and this goes down. So in the same time, we saw it on the SCADA system, and we found that the production of the DC voltage, it goes down to zero actually, and its status shows the turn off in this case. So that's what, if you roam around the entire, kind of, the plant itself, and if you have some sort of the Raspberry Pi, 3 Raspberry Pi, you have the USB dongle, and you script the entire stuff, and if you walk or if you throw the drones or fly the drones over that, you can turn off the entire inverters in this case. And that is a big impact actually, though it's kind of very tricky to do all those things. But same thing, what we found in the SCADA systems, that we can turn off the entire from, if we compromise the SCADA system, or if we are in the SCADA system network, we can send same command not over the Bluetooth but on the Modbus, so we can turn off the entire plant itself in this case. That is part two in the future, but this is what related to strings. As I said, like they have also Wi-Fi communications. So Wi-Fi, they have some sort of the chipset which is not pretty much good in this shape, or rather we can say it cannot handle more packets when we say send arbitrary packets over the Wi-Fi. So this is the same way we use Wi-Fi Pineapple to automate everything. And yeah, over to you.
yeah. So in this case, we get a shell from Wi-Fi Pineapple. In that, you can see we just interface add monitor mode. After that, we use MDK4 for the authentication attack. So when we perform the attack is one of the string inverter. So there is after performing attack, there is a lot big noise is coming from the inverter. Like even the other engineers and people are get scared because
So
that's so loud.
So nothing but the panel which with the inverter have the separate panel from the breaker actually. So separate panel is for communicate over the Wi-Fi, and we perform only DAuth attack. We wanted to perform a lot of type of attacks, proprietary kind of over the Wi-Fi communication, or kind of fuzzing attack on the particular uh, particular service on the Wi-Fi. But first we perform the DAuth attack, and that dissociation packets we send to that particular panel, that creates some sort of a noise. That noise come from the generation actually, not from the panel. Panel is the sub part of the inverter. That was very curious, or kind of fishy thing, that what's happening actually when you control or performing DAuth attack on the chipset. Suddenly it noise very badly, Like the normal noise, I would say very less. Then when we start the auth attack, it creates a lot noise. And then in this field, what happen if we get that particular noise, it get blast. So that there are a lot of chances that we are, if you see the distance, we are nearby in this perimeter or in the area, and we perform those kind of attack, and that creates a lot of noise, and we are afraid that it's going to blast. So we stop that attack, and what happened, interestingly, that we cannot reconnect with this device itself. Like we check like a 2 days, 3 days, but I think so that entire modem, which they use for Wi-Fi, it goes down forever in this case. So it's not able to connect with the inverter. That is biggest problem with the chipset, what they use in this field actually. And there are a lot of chances in the plant itself, if they use the standard, they are not using the standard chipsets or anything, it's going to blast anytime in this case. So that is a weird situation we saw in the plant. So as I said, that the inverters have also the mobile applications, and the mobile application we reverse engineer, and we found some sort of, some API calls are getting called in this mobile application. And then we saw some sort of, URLs where they, in what happened in the mobile application, they connect, restart, and turn on the entire inverter, as well as they fetch the information about the entire status of how much they generated the energy and the status and the health of the device, and getting uploaded to back into the Chinese URL in this case. And that is happening through the mobile applications. So we saw a lot of, the URLs. We intentionally hide this thing actually. And, sorry. Then we found, again, as I said, that there is a login. If you see that AT&T and app and login, they have some sort of the credentials. And from that thing, it takes all the data which are coming in the mobile application, it's going to upload on the Chinese vendor actually. And that is how they also control the mobile app, and from mobile app to the inverter in this case. And what happened, why they use this kind of mobile application for this inverter? Because the system engineers or the administrators from the SCADA system, they want to check regularly the status. They have to drive in the entire plant and check everything in this case. So that's why they use the mobile app. Sometimes they have some sort of problem, they want to troubleshoot, and they can troubleshoot with the mobile app in this case. And that's why once we reverse engineer the mobile application, we found those kind of the IP addresses, and that these IP addresses from the China in this case. So what happens if you block this kind of URLs in this case? So it will reduce the functionality of the app. That's what they've done in the backend. That means if you want to troubleshoot the entire inverter with your mobile app, so you have to allow those kind of IP addresses as well. That's what happened in this case. So another part is I'm going to talk about the coupler. So these couplers being used very prominently in the solar and turbine wind energy in this case. Nothing but they convert to the RS485 to Ethernet. Rather, we can say serial to any sort of communication protocol, that is Modbus TCP or something like that. Even they can convert with the CAN as well. And it ensures interoperability between the heterogeneous system. That means the entire plant, you can see a lot of different kind of vendors or devices, PLCs are there. So for that purpose, they use coupler in this case. And it is oftenly connected with nearby, or I would say like 1.5 or 2 level in the Purdue diagram in the ICS. You can see those kind of devices being used over there. And this is from, again, the Chinese vendor. They come up with the Wi-Fi, serial, Ethernet, RS485, serial communication. They use for this thing actually. So the entire web application is vulnerable. I don't want to talk about this. But the thing is, so now we are focused on the hardware side. So hardware, we saw, which is very small kind of devices and very cheap in this case. You can buy from any vendors, and surprisingly, you can see those devices getting used in the solar plant. And this, what I see that they are using some sort of USR Wi-Fi. These kind of chipsets they are going to use. Same chipset getting used in this string inverter. So the same manufacturer, same firmware, same models over there in the string panel, as well as the string inverter panel, as well as this coupler actually. And this is some sort of 25QC Q16CS. That is the SPI chipset we found. And once we extracted with the by connecting PC byte probes, and we extracted data. There are many things you can use. Testing clip with CH341A or something like that. You can extract the data from the SPI, and a chipset looks like this. It's very used. Everyone used in this market actually, this chipset. And same vulnerability we found. If you get perform deauth attack or fuzzing on the particular Wi-Fi, it goes down actually permanently. So that is the big issue with this. And we use flash ROM, and we use CH341A SPI programmer, and we dump the entire firmware, and we done only strings reverse engineering techniques. So we use strings command, and we found admin, which are not written on the box itself. And there is one thing, if you change the password, it will get updated over here as well. So that means you have a device, in used device from the plant, there would be a chances you will get the credential from the being used in the plant actually. So if you change to admin to anything, you can extract the information or password from the chipset itself. So we found also the telnet communication on the device itself or the Ethernet, and we use a same credentials which we found in the firmware. Rather, we can say not a firmware, it's a data actually from the SPI. And once we type credentials, and we got all information about that, and we able to reboot the entire system itself. So we written the entire script. Whenever it up, again we send same command and shut down the entire the device itself, or rather reboot the device itself. So these are the freaky things happen in the solar plant or wind turbine in this case. So what is the exactly issues? You can see aftermarket devices, or rather you can say the string inverters or the devices getting used in the solar plant. So nothing but they use hard-coded credential. That is very important thing. And they use, if you do those kind of forensics or hardware pen testing, you will get the same ideas, same bugs you can see. Lack of firmware encryption, there is no encryption at all. You will amaze that the producer of, or rather you can say manufacturers who manufactures string inverters or kind of the PLC or SACU panel in this case, they use STM32F0 F1 kind of chipset. So F0 F1 is nothing but very cheap, and not the security standard chipset they use. So that means you can extract the data from the STM32, you can modify in such a way that it acts as a malicious device itself, right? So this is thing you can see in this case, and whatever the firmware they wrote, it's not encrypted at all or not up to the mark. Inadequate authentication mechanism, there are a lot of things in this case. And if you see those kind of common things, its implication is big on the entire infrastructure, wherever you use in this case. So there is a mitigation strategy on the manufacturer's or OEM point of view. So avoid embedding hard-coded credentials in the firmware, which is not good practice at all, as per the standards, OWASP IoT standard as well, and it's kind of common sense in this case. Implement secure authentication mechanism. They should come up with a strong, robust mechanism where they can authenticate or with respect to the device with a strong way, regularly updates and patch firmware vulnerabilities. So whenever you send those kind of vulnerabilities, those vendor, they don't update or don't patch in this case. That is very important aspect over here. You can ask manufacturer. Need to establish secure development lifecycle because these kind of devices are not come from the secure development lifecycle in this case. So in that way, wherever you use these kind of devices in your, in the infrastructure, you should make sure that they should follow these kind of strategies at their development point of view, or you can ask those kind of questions or regularity or compliances from them manufacturer. So that means it should be compliance with IEC 62443, 4-1 and 4-2. So these 4-1, 4-2 is for manufacturers and they have to follow this certification. If they have certification, so operator, they can get those product in and put it in their environment. So if not, so you have to conduct the security audit of devices before getting into the productions and replace or update devices known have hard-coded credential. That means the operator should have responsibility to perform those kind of activities and they confirm whether these devices are free from those common vulnerability at least. Implement network segmentation into limit potential branches. So I saw a lot of things in the solar specifically. The entire architecture is flat actually. So that means there is no firewall, there is no unidirectional gateways or something like that. So it's kind of, if you in the network, or you can create a lot of havoc in this case. Use proper OT-based monitoring mechanism to detect anomalies. So there are a lot of solutions which can be segregate or which can help to micro-segmentation. Even they can monitor the entire network with respect to all OT operations. That means any glitch or any anomalies it detects or monitors in this case. And which is a very important thing, that don't rely on a cheap Chinese products. If the products are the costly, definitely they think about the security things. But if it is cheap products, definitely you are going to have a trouble in the operations in this case. Yeah. Any questions? This gentleman have a question. That is very strong actually.
Yeah, you mentioned that there's a capability or possibility of turning off, let's say, the inverter, etc., right? But I think that's the least of our problems. Um, the thing that I'm concerned about is that although the batteries, the solar batteries, have safeguards, they have controls, right? Settings to prevent thermal runaway. Since it is the inverter which gives or passes the command to the solar battery, someone who has access to the inverter can actually issue commands, right? My question is, um, uh, you may not have the answer now, but I think this is one thing that you should focus on in your research. How can, let's say, an inverter be used to override those safeguards in the solar batteries to induce thermal runaway? But if you have the answer right now, yeah, feel free to answer.
You mean to say how we can hack or the prevention?
Both actually, because the concern is that these manufacturers, or even let's say the so-called threat actor who has access to these inverters, I think that by this time they should already be thinking about inflicting more um, damage than just shutting off the power plant. So I think one way of doing that is to induce a thermal runaway in the solar batteries. So how, first of all, is it possible to issue commands using the inverter so that the solar battery safeguards can be overturned? and this will induce thermal runaway, which will result in fires.
Okay, I got your question actually. So my solution would be for particularly this string inverter would be there should be something kind of the device. Let's think about the micro segmentation. If I say these devices are a legacy product, if I assume that, and these are vulnerable in nature, so there would be a something here, especially this network. This is not exact network. This is like kind of PLC, power line communication happen with one of the SACU panel. This is very half kind of architecture I shown you over there. In the SACU panel, they have some sort of coupler or anything. In this case, what we have some sort of a device which can encrypt the communication to the other side of the master over there. So between those things, the communication can be encrypted with the help of chaos algorithm or any kind of sort of algorithm which can prevent those things actually. So this is kind of another add-on product. We can keep it over there to secure that communication.
Actually, the problem is not, I think, the encryption or preventing anyone from listening in to the communication between the inverter and the battery. It's the need here is actually to prevent the running of those whatever command it is, so that the batteries will be induced to go into thermal runaway. So if you don't have the answer now, I hope you can do research on that.
I think
Yeah.
so. We have to
Yes.
deduce a lot of things about
can speak
the
after.
architecture. Yeah. We'll do that. We'll do that.
Quite interesting. You mentioned that you found some LoRa communications in there, and you said like it was proprietary. So in this proprietary communication, did you see any encryption at all, or like bits shifting, or
Yeah,
'cause,
yeah, so-
like all those Bluetooth and Wi-Fi attacks can be done, but only if you pass the physical access, right? And as you said, you made those drones or something, but it's
Correct.
almost like a weird kind of attack.
Yeah.
But LoRa instead could be an injection point that you could have from long distance, right?
Yes, yes,
So how was it like?
Yeah, I will come to that point. So this, let me bring you something over here. See, this robots, cleaning robots, they have some sort of here, this on the end, they have some, the transmitter that's on the LoRa, and that spread it out of like 100 kilometers. So this plant is 100 kilometers, and you can see a lot of LoRa-enabled robot cleaners are there, and they have communication box. So every like 50 or 60 robot cleaning robots, they communicate with a common the communication box over the LoRa. That could be range around 5 to 10 kilometers in this case. So that we found a bug in this case. We changed the tracker, we shut down the entire the cleaning robot as well in this case. So yes, so they use LoRaWAN, and some of the inverters, which is not mentioned over here, they use LoRa only. So LoRaWAN and LoRa, and they don't have proper encryption in this case. So definitely you can perform DOS again, or the injection you can perform on that, top of that. Yeah. So that was my second part in future. Any
Please,
question?
Any questions, guys, for anyone? No more. I think with that,
Question, could you get one more drink? Could you do one more drink? I'm just kidding.
Thank you so much.
Perfect. Let's give him a round of applause.
And I'm really thanked to RootCon family, especially Jaitullah, Dax, and other friends as well. And this is my second time over here after a long time. First was in 2019, and this is like 2025. I'm enjoying. I love Philippines, yeah.
Perfect. Thank you very much for that, buddy. All right. Before we wrap up for today, all right, I'd like to invite the people that are currently in the sponsors booth over there. If you could come to the main tracks before we close for today. We're giving away a drone. So we're giving away a DJI drone. We never know. Maybe you're the lucky person who's gonna take home that drone. That drone is sponsored by NetSec, one of our sponsors. So they're giving it away. We're giving it away for today, and then very important announcement. We would like